So the point of this activity is to identify the type of factoring. We've looked at 3 types of factoring. So you have to look for the characteristics of the expression that tell you which type of factoring you're going to do, and then carry out the factoring. So let's take a look at the first one. Again, number of terms is a big indicator. This one has 2 terms, so it's not a trinomial. I could look at all of these different questions that fit on the screen, and I could just look at what each of them would be. So 2 terms, 3 terms, 2 terms, 3 terms, 3 terms. I can compare and contrast these and think about the different types of questions. Here's 2 terms, both perfect squares and a minus sign. So that's looking to me like a difference of squares. Compare that to this one, 2 terms, and it's a minus sign, but 24 is not a perfect square. X is just X. It doesn't have the squared on it. And so that's not a difference of squares. These are both trinomials, and they're both of the same form. X squared, X and number, or M squared, M and number. And so they look like trinomial factoring. This is also a trinomial, but it's not in that same form. It's got a Y everywhere. It's got a Y squared, but it's on the wrong side. It doesn't have a constant. It's got an X in there. So to me, that looks like a common factor. That looks like a common factor, not a minus sign. 2 terms, but no minus sign. So that's a big part of the process, is being able to look at each one of these questions and identify the type of factoring. So this first one, as we said, 2 terms and a minus sign, but not perfect squares, so it looks like common factoring. And so I find the greatest common factor, which is a 4, and then I divide it into both. 4x divided by 4 is x, and negative 24 divided by 4 is negative 6. And again, I can re-expand. 4 times x is 4x, and 4 times negative 6 is negative 24, and I should get back the question that we started with. B, 3 terms, it's in the correct form, so it looks like the type of question where I'm looking for 2 numbers that add to 7 and multiply to 12. And we need to get the order correct, so they add to the middle term that has an m in it, and they multiply to the constant term that has no m. And so the 2 numbers in this case are 3 and 4. And again, I could re-expand this. M times m is m squared. M times 4, 4m plus 3m, that gives me the 7m. And 3 times 4 gives me the 12. Right? So if we did that the long way showing our work, we'd get back the question we started with. Always a good idea to think about the connection between expanding and factoring, and always a good idea after you've finished to do a check and make sure that your answer is correct. So again, this one has 2 terms, but no minus sign. It's not a trinomial. It's not a difference of squares. And I see that there's something in common between the 2 terms. The 2 terms both have a factor of 5, and they both have a y. That's right there. If every term has the same letter, you know that you can common factor that out. So let's start with the number. What goes into both 15 and 10? And you're looking for the biggest number, remember? It's 5. And then they both have a y, and just y to the 1, because that's the smallest exponent that's there in every term, so we use that one. So 15 divided by 5 is 3, and y squared divided by y is y. And 10 divided by 5 is 2, and y divided by y is gone. That's just 1. And again, you're thinking about what gets left in the brackets, so that when you multiply by the 5y, what you factored out, the GCF, you'll get back your original expression. It's a good way to think about what gets left in the brackets. X squared minus 9. This is one of those easy ones. It looks like a difference of squares. Everything's a perfect square. As with factoring, you have to know how to write it. So it's going to be split up into 2 brackets. and it's going to start in this case with x and x. Then I take the square root of 9, which is what number times itself gives you 9, so it's 3, and one of them is plus and one of them is minus. Go back and look at the video to see why. But ultimately, this is the kind that cancels out, where I have the same thing added and subtracted. That's the essence of a difference of squares. For this one, there's 3 terms, and so no common factor. I can see that there's no common factor, and I can see that it's in the right form for a trinomial factoring. So I'm looking for 2 terms that add to 1 and multiply to 20. And when I say add to 1, in this case, they multiply to a negative. So that means they have to have different terms. One of them is going to be minus and one of them is going to be plus. I don't usually put the signs in there first. I usually do that after. But I know that because the only things that multiply to a negative are 2 numbers that have different signs. And so the numbers in this case, and then they also have to have a difference of 1. When I subtract them, I'm going to get 1. So it's going to be 5 and 4. 5 times 4 is 20. 5 minus 4 is 1. Which one gets the negative? Is it 5 minus 4 or 4 minus 5 that gives me a negative 1? And so it's going to be 4 minus 5. So positive 4 and negative 5. So this one, again, trinomial. It's got a y squared, but it's kind of in the wrong place. That doesn't necessarily mean it's wrong, but it's got all kinds of other stuff. It doesn't have a constant term. It's got an x, and I see that it has a common factor throughout. So this is a common factoring question, and I can factor 6 out of 6, 18, and 6, and I can factor out a y. And what am I left with? 6 divided by 6 is 1. Y divided by y is 1. That's gone, so I'm just left with the x. You always have to be left with something. That part can't disappear. Remember that. 18 divided by 6 is 3. Y divided by y, gone. 6 divided by 6 is 1. Y squared divided by y is y. Again, 2 terms. 64 is a perfect square. If you don't recognize it, always check. How would you know when to check? If there's a minus sign, then you should be checking to see if that's a perfect square or if any other numbers are a perfect square. And so this one is a difference of squares. And find the square root of 64, which is 8. And make sure you write it in the correct way. 2 terms, but no minus sign, and lots of other kind of junk going on here. There's an x cubed and a z squared, so there's nothing in common between those two, but 7 and 21 are both multiples of 7, so it looks like all I can factor out here is 7, and I'm left with x cubed plus 3z squared. And again, if I re-expand, 7 times 3 is 21. That's why I wanted the 3 when I factored out the 7. So this one, 2 terms, perfect square. I recognize 36 is a perfect square. They're in the wrong order, but that's okay. There's nothing that says that that won't work. And what I want to be careful of here is writing it in the order that the question's given. So I don't want to flip the order back to the other kinds of different square. I want to keep it in the same order. So the square root of 36 is 6 plus w and 6 minus w. What some people might do is write this one as w minus 6, which is not quite the same thing, so that won't work. So I want to leave it as 6 minus w. This one looks like a simple trinomial. It's in the right form for a squared, a number, and y, and then just a number. And nothing in common. This is one of those ones that some people find very tricky because it doesn't seem like there are 2 numbers that would add to 3 and multiply to 2. But often when you start thinking that, it means there's a 1 involved. one of the numbers is 1. So 1 times 2 is 2, and 1 plus 2 is 3. And that can be a really tricky one. And then when I look at the signs, they multiply to a positive. That means they must have the same sign. And if they're adding to a negative, that means their signs must both be negative. And if I re-expand that, I'll see that that works. So for this one, 3 terms, but there's a lot of other junk going on. It's x cubed, x squared, and x. So like I said before, if there's a variable, same variable in each of these, then you can definitely factor that out. And each of those numbers is a multiple of 5. So I can pull out a 5, but I can also pull out an x. So when we divide that from every term, 15 divided by 5 is 3. X cubed divided by x is x squared. That's a great example of how you divide variables. So 3 minus 1, we're subtracting the exponents. Negative 5 divided by 5 is negative 1, and x squared divided by x is x. 10 divided by 5 is 2, so positive 2, and x divided by x is just 1, so we don't write it, so it's just plus 2. Okay, we'll take a look at this last one, and if you need to check answers for the other ones, that will be posted as just a solution set. So again, this one, 2 terms, a minus sign between them, no common factor. I think I can see that clearly. 4 is a perfect square. Some people might not recognize, but 1 is a perfect square, and so I can do a difference of squares for this one. So it's going to look like this. One's going to be plus, one's going to be minus. The square root of 4 is 2, so 2x. Square root of 1 is 1, and then 2x and 1. With the difference of squares, keep in mind it always has to be exactly the same thing in both brackets, except for the sign, right? One's plus and one's minus, but a difference of squares never has a different number here or a different number from each other there. Never, never, never. They always have the same terms, but one's plus and one's minus. That's that special property. Go back and look at when we expand why the middle term disappears and you're only left with 2 terms to see exactly why that happens.